Hi, welcome to FunetPy videos. This is DC here. This is the part 3 of AT88SC102 video series. And in this video, I'm going to show you how to use the security code. I'm going to cover the following topics in this video. So this entire video is all about personalizing the tag. So when you buy a new card, you'll always receive a password called as the transfer code, and you get this from the manufacturer. We're going to see how to change the password or how to change the security code, and we're going to discuss about what happens when the security code verification is wrong, and we're going to see how the card can get locked permanently. And after we verify the code, the security code, I'm going to show you how to update various zones like the issuer zone, the application zone, the manufacturer zone, and the erase passwords. We have seen in the last video that all these zones are not modifiable without the first verification of the security code. So finally, we are going to see how to complete the personalization by blowing the manufacturer fuse and also by blowing the issuer fuse. Now once the personalization is done, we say that the card will work at the security zone or security mode 2. So until then, the card is in the security mode 1. As you can see, I have connected my AT88 reader writer, and I have modified this software a little bit for this video. So you have to have two documents in front of you, the AT88U developer's guide and the Atmel SC102 datasheet. So I'm going to connect to my reader and connect to the card, and I'm going to choose this screen. Now we know that any new card you receive from the manufacturer, it always comes with a default password, and that password is called the transfer code. So you have to use that code to personalize the tag. Most often the first thing a user do is to change the value of the transfer code itself, or to change the transfer code or the security code itself. Now I'm going to show you how the verification is done first. So what you do is you go to this verify the security code tab, and the transfer code for this tag is DC. Now in order to make it clear, I'm going to clear this the screen, hit this verify. Now so many things has gone within within this code. The first thing is we are using the verify security code command, which is defined in this documentation. Now 38U has got this verify security code, which does so many things in the background. It identifies the attempt counter, and it presents the password, and if the password verification is correct, the documentation says you have to verify the value of the SASC counter. Now if the verification is successful, you should receive FF as the value of SASC, the attempt counter. So here what I have done is, after verification, I'm trying to read the value of SASC. I got 2 FFs, so that means the verification is successful, and immediately I'm trying to read the value of the SC, the security zone itself. And we have seen in my previous videos, you cannot read the value of the security code without the correct password verification. Now because of these 3 operations, you are able to see the security code here, and this got refreshed, And once the verification is done, also what you can see here is there's a small tick box here that says SV. This is a security verification flag, which is set as which is ticked here. This is just done by the software. Everywhere in the documentation you'll come across this SV flag. Now internally the card maintains the value of the SV flag. SV flag, when it's ticked, it means the verification success, otherwise it's a failure. So now you know how to verify with the security code. You can modify. I'm going to show you that in a bit. Now I'm going to try this again, but this time with the wrong password. So to do that, you have to reinsert the card, or you can now power down and again power off. So connect and choose this, select the card and read this entire card data. So let us pretend that we don't know the password. So I'm going to verify with a wrong password. So just keep an eye on this SAAC counter, which is the default value here is FFs. Now I'm going to hit the verify. Now the software says verify security code failed. It is because the value of the security code attempts counter did not match with all FFs, and you can see here it is FF, and here if you look at the binary value, that makes more sense. So I'm going to show the binary. Look at that. The first 4 bits is the attempt counter values, and you can go only up to maximum 4 wrong attempts. If you try, I'm going to try again with a wrong password. Look at that, the second bit has become 0 now. So if you look at the first 4 bits, I've got only 2 attempts. I'm going to try the last one, verify, and the third bit became 0. So number of zeros tells me how many wrong attempts has happened so far. If I try to verify again, this is going to make my card useless, because you got only 4 wrong attempts. I'm going to make the right password now. It's DC verify. Look at that, this counter has gone back to this all bits as 111, and you can also see the password which is shown here. Maybe now hex value makes sense. Okay, so I think that I'm not going to make any more wrong attempts. Maybe at the end of the video series, probably I will show you what happens when you go beyond 4 wrong attempts. So we have got the security code verified. The first thing we do is change the password. So I'm going to set this as ABCD. Now write. You can see what's going on here. There is no special command, special write security code command. This is just an ordinary memory write command. Now after the write is done, you can see that this is exactly what I like to show. So when we did the write was I got a completely different value here. So we wrote AB and CD, but what I received is 88 and CC. In fact, there's a small issue here. This should be refreshed. Now if you try to read, look at that. I tried to write AB and CD, but the card has written only 88CC. It is because, keep in mind, in the first 2 videos I mentioned about the difference between write operation and erase operation. Write will always change the value of the bit from 1 to 0. If the bit is already 0, you cannot change that to 1. That's exactly what has happened here. So this basically what it means is, whenever you write to this type of whenever you do any write operation, the bits get logical ORing. It get logical ORed. Now how do you change the password? So I'm going to first erase the memory. So I'm going to erase, because the tag is already verified, the SP flag is set to 1. I can modify this anytime. So I'm going to erase this. So once the erase is done, I can now go and change the password. Right. Now the write is successful. You can see here the write is successful. It is showing ABCD. So now we have changed the password. So you have to keep one thing in mind here. Whenever you change the value of the memory, you have to first erase it, then only you can change. So this is not a rule, it depends on what you want to do. So there may be some scenarios where you like the default way of write operation. You don't want to change 1 to 0. So it depends on what you try to do, because here I want to change the password. The only way you change the password is first erase it and then you write in a new password. So let's try this again. I'm going to erase and I'm going to make my password as A1 and A2. Right, A1, A2. So I'm going to take this tag out and try again with a new password. So I'm going to connect. Now this time we know our password or the security code is A1, A2. If you try to verify with my old password, so you can see here the attempt counter is FE, and if you try to use the right one, A1 and A2, verify, and you can see the new password is this. I'm going to change it back to A, B and CD, so it's easy to remember. Now I can't, keep in mind, I can't just write here. First I'm going to erase. So when you erase, the password is all bits are set to 1, 1. Now I'm going to change this to ABCD, and so right, now my password is ABCD. Now once the tag is tag has verified the security code, you can go and modify any of these sections. So let us try to do the way these cards are programmed. The first thing you like to do is you would like to give a unique, go to the issuer zone. This memory card doesn't have any unique code. So unlike the contactless card like a MeFair, Ultralight or Desfire, where every card has a UID, this card doesn't come with the UID. Now I'm going to first thing do is give just some random value for the issuer zone. I'm going to go A1, A2, A3. Now what you're seeing here is that how to modify the issuer zone. Again, you have to keep one thing in mind, you just cannot write, because writing will just change all the bits that are 1 to 0. It will never change the bit from 0 to 1. So that is what the write operation, irrespective of which zone you are. I'm going to erase. Now there is something you need to know about this erase command here. The erase operation always erases 16 bits. Now there is a nice explanation in this documentation. It's called the erase application zone with erase, not this one. The erase non-application zone. See here, non-application zone means anything which is not application zone. So there are two application zones, AZ1, AZ2. Anything, all other zones are called non-application zones. To erase a non-application zone, the ACS has provided a different command, and it says, if you read this slowly, you'll understand that even if you try to write to any bit, it will erase this entire word of 16 bits. So that's what it says here. Now we know that this go to the issuer zone here. Now the issuer zone is altogether it's 8 bytes. So in order to erase all these 64 bits, you have to say the software provides something called erase size. Set this to 1. So this is 1 byte, and if you hit erase, now you can see that only 1 byte has been erased. Now this is not refreshed. If you refresh here, if you compare this with the previous value, before all these 8 bytes had the value B's, now only the first 16 bits has been erased. Now this is what this command does. So here you specify the address from where the erase should take place and set the length to 000. What this does is all 16 bits starting from this byte address will get erased. So likewise, if you want to erase all the 64 bits, you have to first choose which word. This is the first word, this is the second word, and I want to erase the second word. Erase it, and the grid is not refreshing. Probably that will fix it in next release. So I can see that it's erasing this. Or if you set this as 0, what the software does, it just loops through all the 4 words. You see there are 4 words here. It loops 4 times and erases all the 64 bits. So this is just a shortcut. Hit erase, and if you refresh, now all these 64 bits are erased. Now I'm going to change. Now I can use a normal write operation here. So I want my new application zone to be A1, A2, A3, A4, A5, A6, A7, A8, and if you hit a write, now there's only one single write command here. So you can see that the write here doesn't refresh. Probably that's something. Yeah, if you look at that, is refreshed, so write is successful. Now whatever we discuss here applies to all the zones in this card. So I don't have to spend time explaining these arrays and write and write operations. So we're just going to modify. So probably you can modify this to whatever you want, and you can modify this you have to just go and modify or change the value. It's too many things to type here. Now I'm going to modify this as BB. That's all. Say write. You can see here it's written BB. Likewise, you can go and modify the erase zone. See, what we are doing is personalizing the tag. So I want to keep this so that simple, so that I remember. Now I can use a write operation because the default value is all 00s. If I go and read it, yeah, sorry, it's not the 00. Yeah, probably what I should have done is after the verification success, I should have refreshed this. If you just hit this thing, you come to all the default values. See, there are some zones which you cannot read without the verification. So the best one is probably we are going to change the software so that as soon as the verification is done, you're going to read this entire card again. So you'll find all these zones that are readable only after a successful verification. So here also probably you have to first erase it before you can modify. If you set this to 0, you can erase all these probably 128 bits, or if you want to erase a part of that, you can choose the erase size to 1 word or 2 words, second word and third word, so on. I'm going to set this to 0 and say erase. If you look at the command that are going to the reader, there is a loop happening here. It's just looping 32 times because there are 64 bytes, and just it is erasing 16 bits at a time. If you read, you can see that everything is set to FFs. So now you can put whatever data you want. So I'm going to pause for a while and get some 64 bits of data for you. So 64 bytes of data. I've just got a sample data here that says this is application zone 1, and all the remaining bytes I'm setting that to zeros. So the very first byte I have kept that as zeros, which I'm going to tell you in my later videos why I did that. So I'm going to write. Now you can see that we are writing 64 bytes. There is no facility to write a single byte. Maybe you can provide that in the later versions. If you look at here, the grid has refreshed already, so the write is successful. You can click on read and see that everything is alright. I'm going to change the application zone erase key. Now the way you do that is, first you're going to erase it, click on erase, and if you read, you get all FFs. Then I'm going to change this as A1. All I'm going to set as A1, so easy to remember, because this code I'm going to use in my later videos. So write. So writing is done. Same way now, the way we did here, I'm going to copy this. I'm going to change this into text that says this is application zone 2, and before you do that you have to erase it, and if you just yeah, it's already erased. Now change this data to something we want. Now most often this will be like a customer name or some kind of a identification. Now I'm going to write. So write is successful. I want to change the erase key for application 2 as well. So before you do that, we are going to erase. Now this has been erased. Now I'm going to change this as A2. Now there's a difference here. The length of erase key for zone 1 is 6 bytes, whereas for zone 2 is 4 bytes. Right. Now because the card is been authenticated, you are able to see every zone here. You're able to read data from every zone. I'm not going to play with the application zone 2 erase counter here. So likewise you can change the manufacturer zone. Now this, if you look at the documentation, this is supposed to be the ID of the customer, and most often probably this will be returned during the card manufacturing time, and this will be locked. But my card came with open, so I can modify this. Probably write this as again, every time you just can't write, you have to erase it. Now this change to FF. Now I'm going to write, put my initials DC, write. Now the write is successful, and so we have just personalized this entire card with we have changed the password to, I just have to make a note of this. Now we just change the password to ABCD and change. Probably we did not change this thing. I can change this as well. If you want to know how this erase size works, okay, so set this to 1. When you erase, you can see that this is something. Oh, sorry, I think this is alright. Yeah, we are able to erase only 16 bits. Now if you want to erase the second or the third word, this 1 2 3 third word, say erase and refresh, that third, or if you set it to 0 and say erase, there's a loop going on here that erases all the, you got 8 bytes here, and this can be anything. So you can, I'm going to set this all to zeros or keep it as default Fs. Most often this will be used as a OTP, like a ticketing area. Now I've just reset back to all FFs, and that's all. What you have learned in this video is, we learned how to verify the secure code. Then we learned how to change the secure code, and once the secure code is verified, we are able to write to any zone in this card. So that is called as the personalization. Now assume that I want to freeze this. I want the tag to move from security mode 1 to security mode 2. In order to do that, you have to blow this fuse here. Now I'm going to show you there are 3 fuses altogether. This is the manufacturer fuse, the erase counter, erase 2 counter enable, and the issuer fuse. I'm going to try this manufacturer fuse. Okay, this fuse controls the manufacturer zone data. Now if I blow this fuse, now you can't, there's no write method here. If you look at this documentation, there's a separate command to blow the fuse. So if you look at here, for AT88SC102 to blow the manufacturer fuse, you have to use, see, this is the command structure. The value for this byte is the higher address, and this is the address of the memory where the fuse is present. And if you look at the documentation, the first thing is the documentation tells you where is the memory. Now here, this is the memory address in bits. Now you have to convert this to memory address in bytes. So I think this probably will be in bits as well here. Let's check. Now it says, and it's already given here, so it's a bit address. It says you have to set the higher the value of this byte as 03 and F8, and the state of RST pin is 0. So there are 3 placeholders here, or 3 parameters, and the table has given you the value of all the 3 parameters. So we are going to blow the manufacturer's fuse, and once the manufacturer fuse is blown, now the tag will not, or the memory card will not let us modify the manufacturer zone data. So I'm going to try that. So let me clear the command section. You just have to hit this button, blow. Now there's a warning here. This is like a one-way operation. You can't undo this. If you say yes, now if you look at the command structure that are going here, so this matches what exactly the documentation. Sorry, I was wrong. This is not here. It's this one. It says 05B001. You can see 05B001, and this is always okay, the 01. Now we just followed whatever the documentation says. Now there's no way you can find whether the value of these fuses. There's no separate commands. Unlike there's a next the next version of this memory card, that's SC153, where you can read the values of the fuses, whereas in this 102 you cannot. So the only way you come to know whether it's blown or not blown is try to write it. If you're able to write, it means it's not blown. If you're not able to write, if it's blown. So I'm going to take this thing out and try again. Now I'd like to modify this manufacturer zone. Now before I do that, I'm going to authenticate. I know my new security code ABCD. Verify it's successful, and because it says there's a tick here, and I'm going to modify this, say erase for example. Now looks like the erase has happened. Now how is it possible? We have blown the fuse, which I don't know. I've just followed the documentation. Now what I've noticed is the blow fuse command did not work for me using I've got 2 ACR38U devices. In both the devices I'm not able to blow the manufacturer fuse. So I have emailed the manufacturer waiting for the reply. Now so where do we go from here? The solution is, I'm going to show you the next reader. If you remember, I mentioned about two readers that support this tag. That's the ACR1281U. So the same command works in ACR1281U, and this is a dual interface device which is pretty expensive. So you can see I've connected my ACR1281U reader writer. So this device is pretty huge compared to the 38U. Now this is a dual interface reader. I'm going to choose. You can see it says ACS ACR1281U dual interface. I have to choose the IC01 because the PIC01, this refers to the contactless card. Now connect. Choose this card. All these commands work with both the reader writer. I'm going to authenticate with A, B, C, D. The verification is success. Now we are going to blow the fuse. The manufacturer fuse is here. Blow. So the fuse it says for every command you always get a successful response here, 9000. Now I'm going to see if I'm able to modify now, or do I have to now take out the power or reactivate the card. The manufacturer zone, it's already cleared. I'm going to set this as say all as A0 A1, right? Now look at that. Here the write is not successful. Now I should have written something and blown the fuse. So now we have the manufacturer fuse is blown. You cannot modify the manufacturer zone data at all. Try to put zeros and say write. Because the write is not successful. So the only one thing that's missing in ACR38U is with this command not working. Alright, thanks for watching, and the next video we're going to now cover the remaining stuff, like how the card behaves in the security mode too.